Good evening. Welcome to YouTube classes, Unacademy YouTube classes. Here, Unacademy is providing good facilitations for the aspirants, those who are seeking for getting rank in EAMCET examination, either in AP level or TS. So, for EAMCET examination, the one who is interested, you can opt for this batch named as EAMCET Rankers batch, and recently it is started on 24th December. Okay, very freshly it is started, and you can use this code VV Live to get a concession 10%. And also students, being Unacademy students, you have to go for this plus subscription, and for that code is VV Live. And what are the advantages you are going to get due to taking out this subscription? For that, I can say you are going to get premium content at affordable price, okay, reasonable, and structured live courses will be conducted. Apart from that, dedicated live doubt clearing sessions will be there. Quizzes will be conducted at regular intervals. Batches for complete preparation. So you are going to get a complete preparation from n number of batches, that is your wish. For any batch you can opt. And Unacademy is providing daily practice papers, fill in the marks, and with detailed analysis. And students, I can say that this all you are going to get with a single subscription plus subscription, and you are going to opt for this VV code. By that you are going to get 10% discussion. And proudly I can say that Unacademy is providing 20 plus top educators, right, in this plus courses or classes. 10 plus batches are there, 250 plus courses altogether, and many more, like 2000 plus lessons, and daily it's going to update. Unacademy is going to update. Students, for this all you have to use this code VV Live to get a subscription. And coming to today's our discussion, in this present session we have to discuss about thermodynamics part 1. So we have to discuss about thermodynamics part 1, means lesson 1, thermodynamics, right, lesson 1. We have to take this discussion. So what exactly thermodynamics? Thermodynamics is nothing but a branch of physics. We know that thermodynamics is basically branch of physics. And what else? What it can discuss exactly? For that, if you are asking, I can say this thermodynamics deals with the thermal energy conversion into other forms of energy. In olden days, it is said to be thermal energy. Means what? Heat energy only. Thermal energy to mechanical energy, like that. In olden days we are called for this thermodynamics. Now it's not exact, not only into this mechanical energy, as we know different forms of energy in our nature, we can say, we can see, we can encounter in our daily life. So this thermal energy into, right, this thermal energy into all forms of energy, all forms of energy means what are the forms of energy we have? In general, many forms of energies we can see. Suppose light energy, from morning we can see, morning to evening. During the daytime, light is coming from star, sun to earth surface. And I can say heat is energy form. It's also again from sun star we are getting. And the sound we are able to experience every day. Now I am speaking. When I am speaking, I am going to release this sound waves, right? Next, many kinds of energies like electrical energy. For example, if I say electrical energy, without electrical energy, we may not see this colorful world. You know that. So, like this thermodynamics, this thermal energy to mechanical energy. Okay, not only this mechanical energy, all forms of energy. Now, modified statement is thermal energy conversion into other forms of energy we can discuss. Of course, here already if I write for this heat energy, you can go for another kind of energy like wind energy, for example, wind energy. Okay, many more nuclear energies are there and likewise. So students, here what we can conclude is thermodynamics is the branch of physics. Okay, it's a part and parcel of physics only. And mainly it is discussing the conversion of thermal energy to other forms of energy. Right? In that sequence, we are going to solve for different kind of problems. And before to that, a few things we should understand before entering into this. Means the basic things in thermodynamics, what we have. Students, in this thermodynamics actually, we are going to deal with the gaseous state of the matter. As you know, matter is of three states. It is in three states like solid, right? Solid state, liquid state, right? Next, gaseous state. So, in this gaseous state, okay, for this gaseous state, this thermodynamics is applicable. Be remember for this. Okay, many gases are there in our nature. Every day we can experience. We may not see the gases, but we can experience like how we are daily. Means every second, every minute, how we are taking this oxygen and we are going to send out from our human body like a nitrogen, okay, and a composition of other gases also we know clearly. So here this thermodynamics mainly deals with the gaseous state of the matter. It's a clear point. Now in this, what else? What actually we have to know more about? So for this I can say in this thermodynamics we should know about system first. System is nothing but it is a gas under our observation, right? It is a gas under our observation. What kind of gas, sir? Like we know, we have ideal gases, right? Real gases. Of course, ideal gases are not there. Okay, name itself saying it is ideal. So a gas which obeys all the gas laws is said to be ideal gas. We know that. Now in those gas laws, all the gas laws like Boyle's law, Charles' law, Gay-Lussac's law, Avogadro's law, all those four laws, if any gas is obeying, that is called ideal gas. But actually what we have about real gases. We have real gases, ideal gases only for the sake of ideal. We have, right? So here, okay, any gas is obeying all those four laws, it is said to be ideal gas. So now here in this, we have real gases in our nature. So that gas which is under our observation, suppose you are considering certain amount of gas in a cylinder. That for that cylinder, inside that gas is present, inside the cylinder gas is present. Na? For that gas you may expand it, you may compress it. It means you may compress the gas or you may expand the gas like this. You see here. Suppose imagine one gas in the cylinder. Say this is the cylinder. Here it is the cylinder, friends. Right? In the cylinder, molecules are there. Gas molecules are there. So many gas molecules are there like this. Here this is the frictionless piston. This is the gas, which is nothing but system. Right? This is totally, it is said to be cylinder. So this is nothing but gas cylinder. In this gas cylinder, gas is nothing but system. These are said to be ideal gas molecules and this is said to be frictionless piston. So while it is moving towards these gases, away from the gases, friction is not countable. Friction is absent, like that we have to assume. So now in this case what I am saying, in this thermodynamics very primarily, system is to be imagined. And this system must be separated by, one thing is called surroundings. Surroundings. So system and surroundings are separated by, okay, this system and surroundings are separated by using one imaginary boundary. This is imaginary, right? Imaginary boundary means boundary can separate system and surroundings. You can ask what exactly surroundings are. Surroundings nothing but except this system means gas, whatever it comes under beyond this boundary, that is called surroundings. So the entire world, entire universe, is taken as a surroundings. It should be treated like a surroundings. System means a gas which is under our observation, that is system. Now here, for this if you see, this system, systems are of three kinds basically, students. Systems are of three kinds. Suppose you see, like this, okay, like this one system we can imagine. We can imagine for one system. Now suppose, from in this system, means this is gas, no? Basically gas. Gas means gas molecules are there. Gas means gas molecules inside. Okay, gas means it's made of molecules only, no? It's molecule, right? Means it's basically matter. So molecule can have energy also. Molecule can have energy, like heat energy you can. And also you know the universal fact that this entire universe is filled up with either energy or matter, isn't it? Either energy or matter. This entire universe, this universe is filled up with these two only, isn't it? So for that what I can say, these gas molecules are having, these gas molecules are nothing but material particles. I can say this as matter. It can have some energy. Gas molecule will vibrate simple harmonically always, means a simple harmonic motion it can do always about their mean position, students. Sorry. So simple harmonically gas molecule can vibrate from its mean position. So thereby I can say it has its internal energy. So basically I can say this as energy. So this gas is having it is nothing but combination of these two, matter and energy. Sorry. Now students, you see here, this matter and energy can able to exchange with this surroundings. This is surrounding, we know clearly, surroundings. This is system. So system to surroundings or surrounding to system, if both matter and energy are exchangeable, that is said to be open system, students. That is said to be open system. Open system. Suppose if both are not able to transfer, that is isolated system. That is isolated system. If suppose only energy can be transferred on either side, that is said to be closed system. That is said to be closed system. Very simply we discussed, students, here. Systems are of three kinds here. Open system, isolated system and closed system. In this you observe very carefully. In open system both matter and energy can exchangeable in between surroundings and system. Whereas in case of isolated system, both cannot, neither matter nor energy can exchange between system and surroundings. Whereas in case of closed, only energy can be exchangeable. In case of closed, only energy can be exchangeable between system and surroundings. Okay, this is the very basic thing. And also, students, here about energy, if you are asking, I can say about internal energy of the gas. Internal energy. Internal energy. We need to speak about internal energy. Generally, any gas is having its internal energy. We have to speak about always changes in internal energies. Be remember for this. So, generally, internal energy can be denoted by letter this U. But while you are discussing, in case of any given situation, when the turn comes to discuss about internal energies, we have to speak about change in internal energies only. Now, what exactly this internal energy, for that we will see. See, students, this is the cylinder. Now in this cylinder, right? This is the frictionless piston, right? This black color diagram gives frictionless piston. Okay, this is totally cylinder. Inside the cylinder, gas molecules are there. These are the ideal gas molecules. We remember these gas molecules always collides elastically, perfectly elastic collisions. These can make. Okay, students, these can make for perfectly elastic collisions. Perfectly elastic collisions. As you know, perfectly elastic collision means both law of conservation of linear momentum and law of conservation of kinetic energy will be obeyed in case of perfectly elastic collision, right? Now you see. Now these such type of molecules, gas molecules are there inside the gas cylinder, right? Somehow, students, somehow you are going to give heat energy to this. What happens, you see? As already we discussed before, these molecules can vibrate about their mean positions. So, due to configuration, what I am saying is configuration. Due to configuration, these gas molecules are having potential energy, and also due to molecular motion also these are having kinetic energy. Suppose even though you are not supplying the heat energy, what happens, you know, these gas molecules moves with RMS speeds, always root mean square speeds. So with this root mean square speeds, always these gas molecules, ideal gas molecules will move. So due to that motion, it is having kinetic energy. So therefore, students, you see here, internal energy of the gas molecule is due to potential energy of the gas molecule and the kinetic energy of the gas molecule. Suppose somehow if you are supplying for the heat energy, these gas molecules can absorb that heat energy, and its velocity goes on increases, and thereby these gas molecules can exert a force on this piston, and these gas molecules can increase the temperature. This is the important observation, students. As we are supplying the heat energy, suppose heat energy is supplied to the gas, what happens? These gas molecules can absorb this one, absorb the heat energy. So by absorbing heat energy, its temperature increases, right? As temperature increases, internal energy change also more, means internal energy will be increases, means as temperature change is increasing, internal energy change also increases. Students, this is a very important point. This is very important point, right? So now you see, means here from this what I am going to conclude here is, right, temperature change decides the internal energy change. This only can change, means internal energy depends only on temperature. Internal energy depends on only temperature of the gas or system, I can say temperature of the gas. Be remember, as temperature of the gas increases, internal energy increases. As the temperature change is decreasing, internal energy change also decreases, right? So likewise, how it is changing, that we are seeing, that we can see. As temperature increases, what happens? The speeds will increase, molecular motion will increase. Thereby automatically in this internal energy of the system will increase. So far now what we are seeing, in this case of thermodynamics, what is system, what is surroundings, what is boundary, and how those are separated. In system, what we have, system means what, and in that, like matter and energy, if it exchanges or cannot exchanges with the surroundings, how we classified the system types, we are seeing for that. And internal energy, about internal energy we are discussed, right? And next about heat and energy we will discuss, students. Heat and energy. Now we are in the thermodynamics part. Here terms like heat and temperature we have. Okay, how to differentiate from this? How to differentiate? You see, students, heat is basically form of energy. It is basically form of energy forms, as we seen in the beginning. Whereas temperature is, it's a degree, means degree of hotness or coldness of a body, means whether if it is hot, more temperature, if it is cold, less temperature for that body, we can assign. So this is the degree of hotness or coldness of a body. So okay, right. Suppose if it is more hot, its temperature is more. Okay, if it is cold, then temperature is less, like that we can say. And as you know, these both are scalars only. These two are scalars only. This is scalar, even this also scalar. Why? Because there is no specified direction for heat. It's basically energy. Energy, work done, power, these are scalars as we know. And even this temperature also is scalar quantity. You see, room temperature is 27 degrees centigrade, like that we will take usually. So room temperature is nothing but 27 degrees centigrade, like that we will say. Right? Yeah, this 27 degrees centigrade, for this 27 degrees centigrade, we cannot assign these directions, like it is north side, right, 27, like it is south side 27, like it is east 27, west 27, like that we are not giving. So therefore here no specified direction. For whom? For temperature. So therefore what we can say, even this temperature, okay, is also scalar quantity. For both units are there. And for heat energy, what is the unit? It is basically joule is the unit. Okay, we have to call actually this as joules. Okay, suppose we can say it as a joule also. Joule, here this unit is Kelvin. Temperature SI unit is Kelvin. Of course, practical units may be degrees centigrades, but SI unit is Kelvin. Right, like that, these are the basic things. Right, and also heat. Regarding heat, I have to put one point. Heat is always always need not to write. Heat is in transit. That's it. Heat is in transit. So see students here. Heat is in transit. What it means, you know? Always heat is in flow. Means like here you see this example. Simple example I will give. Here is one body. Say this body is A. Here is another body called B body. Here it is another body called B body. Right? Suppose if this A body is hotter than this B body, I can say T1 is greater than T2. Right? Now see students carefully. This in this A system, means here it is gas molecule. It is with gas molecules. Of course, even this B also. Right? It has its internal energy. It is having its internal energy. Means as gas molecules are well inside the system, gas molecules are well inside the cylinder, then these can vibrate about its mean position simple harmonically. So therefore these are having its internal energies. So I can say this as UA. Likewise, even for this B gas molecules also internal energy B will be there, UB will be there. Where UA is the internal energy of the system A, where UB is the internal energy of the system B. Are you clear with this? Now, suppose we are going to bring these two bodies together. Means we are going to make a contact between these two bodies like this. Right? This is system A and now this is our system B. Right? Like this. These are going to brought in contact. This is system B. Now students, what happens, you know, here gas molecules are there, as you know, gas molecules are there. So now, being a difference of temperatures of the bodies here, T1 is greater than T2 now. So from this hot body to, this is basically hot body, this is cold body, right? This is hot body and this is of cold body, right? From this hot body to cold body, right? Energy flows. This energy flows. Isn't it? Which energy is flowing? Internal energy is only flowing. That flowing internal energy, I can say what it is. That flowing energy is only said to be heat energy. Means the difference of energies like UA is greater than UB. So UA minus UB is only the heat energy. This is only the heat energy, be remember. So now in this what I am going to say is, whenever two bodies are brought in contact and there is a temperature difference between the two bodies observed, then from hot body to cold body energy flows, heat energy flows. Whenever this heat is entering into the second body, whenever it is entering into the second body, right? Likewise, when both bodies temperatures becomes equal, means T1 is equals to T2, which I can say it as a T, that condition is said to be thermal equilibrium. This condition is said to be thermal equilibrium, right? Thermal equilibrium. So whenever thermal equilibrium state reaches, then heat stops flowing. Then what happens? Heat stops flowing. Heat will stop. Heat stops flowing from A to B, because now temperature of A is equals to temperature of B, and common temperature I am calling it as T. So now you see students, whenever this heat is flowing from A to B until thermal equilibrium reaches, until this thermal equilibrium condition reaches. What is thermal equilibrium? Both bodies temperatures must become equal. Okay, till that time only, until thermal equilibrium reaches, till that time only heat flows. Once that energy enters into the second body, we have to call this as internal energy of the second body only. Be remember, here internal energy of this first body is UA, internal energy of the second body is UB. See students, here I am going to clear one point. What is that? Whenever energy is flown into the second body, we should not call that energy as heat energy. It is to be called as internal energy of the second body here in this case. Internal energy of the second body. Now before here some energy is there, that is again internal energy only. Only the meantime, the energy which is flowing in between these two, that energy is only said to be the heat energy. Once again I am repeating for this. That energy is only said to be the heat energy. That is the reason why students, we don't have sentences in science like heat of the body. Suppose here you see heat of the body, right? And next heat right, contained by the body, heat contained by the body, right? These sentences we don't have in science. These sentences we don't have in science, because heat, why it is said to be like that? Heat is in transit always. Heat is in transit always. It should be in motion. Energy should be in motion. That energy, whatever it is flowing from first body to second body, that energy is only to be called as heat energy. This energy is only to be called as heat energy. Once if it enters into the second body, it should not be, it must not be called as heat energy. It should be called as, it must be called as internal energy of that particular body in which it is flown, right? So likewise. So these are the things in lesson 1 we discussed, students. You see, just give a glance for all of this. Very simple things. Thermodynamics, this lesson 1 we discussed very simple things and fundamentals. These all are nothing but basics. You take any competitive examinations, they are going to ask from the basics only, students. So be careful and be alert. Suppose you see here what we have discussed about system, surroundings, boundary, and on gas cylinder we are taken, and 3 system types we are discussed, like open system, isolated system, closed system, and also we are seeing vibration of the molecules, right? And next here you see internal energy is due to the potential energy of the gas molecule and even kinetic energy of the gas molecule. Whenever motion is there, kinetic energy takes place. If motion is absent, only configuration gives the internal energy, right? So as we know, gas molecules, ideal gas molecules always moves with RMS speeds and collides elastically. Collision is the example for perfectly elastic collision. Ideal gas molecules collide perfectly elastically, which means conservation of linear momentum and conservation of energy laws will be obeyed. And also we have discussed Okay, internal energy depends only on temperature. Internal energy depends only on temperature. As temperature increase, internal energy increase. As temperature decrease, internal energy decrease. And we are seeing the differences between heat energy and temperature, right? And both are scalars. And now we are seeing the definition of heat energy also, how it is flowing, and always it is in transit. That statement is very important. This point is very important. Always heat is in transit, right friends? So like this we have this session, and thank you for all for listening this, right? So with this today I am going to close for this session. Thank you for watching.